Hi, welcome to my first video on YouTube. If you've clicked on this video, well then you're in for a tricky physics problem. This problem is from Canada's hardest physics exam, and it's one of the easiest. It's from the CAP's High School/CEGEP 2018 Physics Olympiad. Link in the description if you want to see it. So, it's said that out of 2,000 students that take the exam, only 50 to 100 students get a grade above 50%, which is absolutely crazy. So without further ado, I'll read out the problem, and if you think you can solve it, well then pause the video and give it a go. So let's get right into it. Consider the arrangement of springs shown below. All springs shown have a spring constant K. The first layer contains one spring, the next two springs, the next four, and so on, with the nth layer containing 2 to the n minus springs. What is the value of the spring constant of the entire assembly in the limit where the number of layers n goes to infinity? So to understand this problem, we need a little reminder of what Hooke's law is. Hooke's law states that the force that a spring has when it's either compressed or elongated is equal to the spring constant times x, where x is equal to the distance that the spring moves from its natural position. Now, when two springs are placed one after the other horizontally, like in this case, we can say that these two springs are placed in parallel to each other. Now, when two springs are placed in parallel to each other, we can write down that the equivalent spring over here, that spring's constant is equal to the sum of the spring constants of the first spring and the second spring, giving us an overall stronger spring, a stronger equivalent spring than spring number 1 and spring number 2. We can't have a negative spring constant. So what this means is that when we place two springs in parallel to each other, we get a stronger spring. So we get a stronger elastic force. And for example, when we're in a trampoline, trampolines are composed of springs in parallel. And those springs come up to make an equivalent stronger spring. And if the spring constant is higher, well then the force is higher. And if the force is higher, then we get pushed up further into the air, creating a greater sensation of fun because we have more acceleration, more force. We feel like we're getting propulsed further up into the air. So this makes sense. So for springs in series, when we have one spring placed one after the other but vertically, like in this case, well then the equivalent spring is going to have a constant that's actually smaller than the springs that compose it. And it's given to us by this formula right over here. So now that we know the formulas for equivalent springs constants, we can go ahead and solve our problem and simplify it. So this whole cake of springs over here, it's going to be equivalent to a very simplified version. So in each layer, we have springs that are in parallel to each other. And now, since the constant of the equivalent spring for springs that are in parallel to each other is equal to a sum, but in this case all the springs have the same constant k, well then when we simplify our system, we actually get something a lot easier to deal with, because we know that each of these springs have the same constant, and so it's just going to be a multiple of the number of springs times k. In this layer we have k because there's one spring. In the second layer we have two springs, so our spring constant will be 2k. In the third layer we have 4 springs, so our spring constant is going to be k plus k plus k plus k, giving us 4k. And in the next spring, if we go on to infinity, well then it's going to be equal to the number of springs times k, and the number of springs in each layer is given us by the problem. The number of springs in each layer is 2 to the n minus 1. So the spring constant will be 2 to the n minus 1 times k. Now, if you've noticed, all these springs over here are placed one after the other vertically. So this means that all these springs are placed in series to each other, and we have our formula to find the equivalent spring constant of the entire assembly, which, if you recall, that's what we're here for. That's our problem. So we can write this down. We can write that formula I just erased to express this infinite large series of springs. So 1 divided by k equivalent is going to be equal to 1 divided by k plus 1 divided by 2k plus 1 divided by 4k and to infinity. These dots mean infinity. So now that we have that out of the way, we can, if we see this, this should sort of ring maybe a bell. This is actually just an infinite sum of terms. And an infinite sum of terms is a series, if you recall from your calculus classes. Now, we can write this down as the series. So the sum as n is equal to 1, that goes to infinity, of 1 divided by k, of 2 to the n minus 1. Because here, we're adding up 1 divided by k, but times a multiple of 1 divided by the number of springs. So 1 divided by 2 to the n minus 1 represents the number of springs in each layer that we're adding up. Now this isn't just any series, it's actually a really special series that we see a lot. This is, if you recall, it's a geometric, geo for short, it's a geometric series. Now, geometric series are in the form of the infinite sum from n is equal to 1 to infinity of a to the r of n minus 1. Now, in this case, our r is equal to 1/2, and our a, which is the constant it's being multiplied by, is equal to 1 divided by k. Now, series, as you may know or may not know, converge to a certain value. Conversion means that it goes, all this infinite sum is going to add up to in a finite value. And it only adds up to a finite value that if the absolute value of r is smaller than 1. And in our case, we defined r as being 1/2. 1/2 is indeed smaller than 1. So we know that the series is going to converge to a value. But to what value it converges to? If you remember, geometric series converges to a divided by 1 minus r. So we can write this expression as being equal to the value that the series converges to. And what the series converges to is 1 divided by k, which is a, so a divided by 1 minus r, which 1 minus 1/2. And this gives us 2 divided by k. So we have this over here. And I'm just going to simplify this over here. So we have 1 divided by k equivalent is equal to 2 divided by k. And all we have to do now is just put it to the minus 1. And this gives us that our final answer is equal to 1/2 of k, which is the multiple choice A. And that's it. So I hope you enjoyed it. If you have any questions, feel free to leave it in the comments. And thank you for watching.